This video is going to address some external resources specifically useful for chemistry. So let's go ahead and get started. In order to understand chemistry, you have to be able to read and understand the information on a periodic table. So here, this is the periodic table of the elements. Periodic means that the pattern repeats itself. Okay, let's take a look at one of these. So you have the atomic symbol, the atomic number, the atomic mass, and then you have the general location of where it is and the color codes. So this gives a lot of information over here on this website. Hopefully this could be a good resource for you. I'm going to show you some simulations that can help visualize some of the things that are not included in the Ingenuity course. In Chemistry A, you start in with atomic structure in the periodic table. The PHET, the PhET simulations here. This is from the University of Colorado. It's phet.colorado.edu. And take a look at the chemistry simulations. So here is, I'm going to build an atom. Here the periodic table shows me that that's hydrogen with 1 proton. Shows me that that's helium with 2 protons. It also says that this is a positive ion because I need to balance out the positives with the negatives. So this would be 1, 2, 3, 4, 5, 6, 7, which is what this is. This is lithium-7. That is an isotope of lithium that is stable. This is lithium-6. Now lithium-5 is unstable. Okay, so we've got protons, neutrons, and electrons here. You could use this simulation. Let's take a look at build a molecule. Okay, we got some really nifty sound effects. Let's go ahead and turn those off. So here are some collections of molecules that I want. This is H2O, which means we have 2 hydrogens bonded with 1 oxygen. And this would be covalent or ionic. That would be covalent because you have a nonmetal bonded with a nonmetal.
Okay, our next collection would be an oxygen and a hydrogen. Carbon dioxide is a CO2. And a nitrogen is an N2 molecule.
So you can play around with this just to get the idea of how molecules fit together. That's a decent one to use. Another one that I like to use is reactants, products, and leftovers. This helps me visualize what a chemical reaction is like. It's kind of like making a sandwich. Go with molecules. This is 2 H2 molecules. 1 O2 molecules can give us two waters. So 2 H2 molecules plus 1 O2 molecule can give you 2 water molecules. These bonds break and new bonds form. This is before the reaction happens, during the reaction, and then after. So this is a different one to combust methane. This says I need 1 CH4 molecule as my raw materials. I need 2 oxygen molecules, and I would end up with a carbon dioxide and 2 waters. So this gray carbon is the same carbon as that one is. It's just rebonded. These hydrogens are the same hydrogens over here, and these oxygens are rearranged over here. So this is what the atoms look like bonded together in this arrangement before the chemical reaction happens. This is during the chemical reaction, and then this is after the chemical reaction happens. Now this doesn't say that we only have 1 CH4 total. That would be microscopic. You wouldn't be able to see it. You got billions of them. What this is saying is for every one we have to have 2 oxygen molecules to come up with 1 CO2 to 2 waters. So if this is 1 billion of these, then I would have to have 2 billion of these, and I would end up with 1 billion of these and 2 billion of those. These are just ratio numbers. It helps us to understand how many raw materials are needed. So this can help you visualize how chemical reactions work. About molecule shapes. Real molecules, this is beryllium chloride. These bars represent the actual bond. That's a trigonal bipyramidal. This is an octahedral. So they have these different names for the different shapes. And you can show the bond angles. So I like simulations. Simulations help me visualize things because I can tinker with them. They're really good with chemistry because you could mix some substances together, but that doesn't really tell you what's going on an atomic level or a bonding level. So this is Isotopes and Atomic Mass. So this is hydrogen 1. It's H-1 and it's stable. This is H-2, which is stable.
So we could maybe take a look at helium, or lithium, or beryllium. The isotope is just taking a look at how many protons and neutrons make it stable or unstable. Okay, so beryllium-9 is a stable isotope. An isotope is a version. Now this shows me abundance of nature. Abundance of nature, there's only beryllium-9, basically. But if you take a look at lithium, lithium-7 accounts for 92.4% of all lithium in the universe, where maybe lithium-6 is the other almost 8%. So you can find both lithium-6 or lithium-7 in nature. Anyway, that's some simulations that I've used to help.
Chemical bonding in molecules. We have types of chemical bonds, ionic bonding. Just wanted to show you where you see some of this stuff. So this is javalab.org. Ionic bonding and covalent bonding are the two most commonly talked about types of bonds. So let's take a look at this simulation for ionic bonding. When you have an ionic bond, it's the force of attraction between two charged particles. So there should be 8 electrons on a valence shell. There are 1 here and 7 here. So they can work together, if you bring them together, to where the sodium now becomes an ion. It donates its electron to the chlorine, and now they're both happy. But the result is there's a charge imbalance. Sodium becomes positive, chlorine becomes negative, and it's kind of like a magnetic attraction, positive and negative. So this is ionic bonding. It's basically a bond that happens between 2 or more atoms. It's an electrostatic attraction because one atom will become an ion by donating its electron. Another one will accept the electron and become a negative ion. So here we kind of see the visual of what's happening. Typically with an ionic bond you have a metal and a nonmetal bonded together. Magnesium is a metal, chlorine is a nonmetal. So that's ionic bonding. Let's take a look at covalent bonding. This site goes through what is a covalent bond, and it talks about single, double, and triple bonds. Each one of those bonds is an electron pair is being shared. So here you have 1 pair, 2 pair, 3 pairs. That's a triple bond. Triple bonds are stronger than double bonds, and double bonds are stronger than single bonds. Let's take a look at the situation here. We have hydrogen atoms, and their outside shells are not full. Now the first ring can only hold 2. That's the s orbital. And they can work together to make both of them happy by fighting over an electron pair. This is a single bond. O2, you've probably heard oxygen referenced as O2, and that's because the particles, they look sort of like peanuts. This is a double bond. See, they're fighting over 1 electron pair here and a second electron pair here. So this is a double bond for O2 gas. N2 is a triple bond. It's because there's 5 in the outside shell. It needs to gain 3 on each one, and so it fights over 3 pairs, and it counts for those 3 pairs count for both. Hydrogen and oxygen form water by 2 hydrogens connecting to the oxygen. It looks like Mickey Mouse. So this is a polar molecule. You may have seen that in your chemistry class. Carbon dioxide is 1 carbon and 2 oxygens covalently bonded together. Covalent bonds are basically nonmetals. So carbon is a nonmetal, oxygen is a nonmetal. This is ammonia. It's NH3. It's 1 nitrogen, which needed 3 extras. And then you have covalent bonds with the hydrogen atoms. So this is a simulation that shows bonding. The investment that you put into working with simulations can actually save you time when you're taking the quizzes. Just thought that that might help a little bit.